This video is the first in a series about primitives and reference parameters. In this particular video, we'll review the two kinds of data available in Java, primitive types and reference types. And we'll learn about how they are used differently when we use them as arguments or parameters in a method. So first, let's review the definitions of the two different types of variables. You probably remember that there are primitive data types in Java. Those are simple variables that hold a single piece of information, like an integer or a double or a character or a Boolean. Here are some examples of primitive variable declarations that we've used throughout the semester. Things like int index, that's a primitive type. It's storing one integer, or Boolean found, that's a primitive data type storing one true or false value. In context, there's also a slightly more complicated data type. Those are called reference types, and those are used to store variables whose data type is defined by a class. That includes variables of the string class, the scanner class, the array list class, all the different classes that we've looked at that are part of the standard API. And it also includes single and multi-dimensional arrays, which we've talked about. Reference variables are declared with syntax that looks like this, where you always have the data type, and it's always a capitalized word. Then you have your variable identifier, whatever you choose. Then you have an equal sign and the reserved word new, indicating that you're allocating space. And then finally, you end the declaration with the name of the data type again, with parentheses after it. In a few weeks, when we learn about defining our own classes, our own data types, we'll learn more about this particular syntax and what it means. We've also seen the declaration for arrays. They have a slightly different syntax, but they still declare a reference variable. Remember, array declarations look like this, where they have the data type, which has to be a primitive, then the square brackets to indicate that it's an array. Then you can pick any name you want for your array, and you use the new syntax again to allocate space for the variable. One of the key differences that's a big tip-off that can tell you whether something's a primitive type variable or whether it's a reference type variable is whether the reserved word new is used in the declaration. You always use the reserved word new when you're declaring a reference type, as you see in all of these examples, but the reserved word new is not used when we're declaring primitives, as you saw in the examples up at the top. So you might be wondering, like, why do we need that reserved word new? What exactly does that mean? And so we're going to talk about that a little bit. What's going on in the memory of the computer behind the scenes? So when you declare a primitive type variable, Java sets aside a really small amount of space to store that single value. And when you access a primitive variable, Java thinks about the value that's stored inside that box. So if you declare in your program an integer primitive typed variable, int position, and set it equal to the value 8, what Java does is to set aside a box of memory, associates your identifier, should be position, sorry about that, position. Oh, it's going to be funny and like not put it in the right spot. Pretend like it's over on the other side. And then I'm just going to leave it alone. And then it stores our value 8 inside that box. So that's what happens for primitive types. When you declare variables that are reference types, Java stores a reference to another chunk of memory. And that's why they're called reference types. So for example, if we declare a variable array, and we say that we want to allocate space for 10 different integer values, what Java actually does is set aside a box for the variable array where it stores a memory location. And in Java, memory locations are usually denoted with hexadecimal values. Hexadecimal values are kind of funny kind of numbers. You'll learn about them when you take our applied discrete mathematics class. Hexadecimal numbers have digits in them that can be 0 through 16. And so letters are used for the numbers 10 through 15. there's 16 different values in a hexadecimal number. And so sometimes when you're looking at it, it looks a little bit funny, like it's a string, but really I promise that that's a number. So it's setting aside the variable array, and then inside this box, it's storing the memory address of another memory location. It's the memory location where it set aside all the space for the various array values. So my box for array stores a reference to the memory address that actually stores the data value. And again, that's where the reference type or reference variables get their name. You can actually see this difference in Java if you write a little program and you set up, a primitive value like position, and you set up a reference type like array, and then you print out the two data values. You can see that the output looks really different. For the primitive data types, it stores the value that you were associating with that variable. But when you print out the value of array, it doesn't print the information that's inside the array. It's printing the memory address where that array exists. And you can type that program into IntelliJ yourself and then run it just to see that I'm not lying. Whenever you run it, you'll see that it stores a variable, and then it'll store or print out the memory address of the array. For you, it might not be exactly the same memory location because it just decides on the fly, like where do you have memory space available on your computer. So you might be wondering, why does this matter? Why do I need to know about how the computer stores stuff as memory addresses or actual values? What does that have to do with anything? Specifically, what does that have to do with methods, which is what we're learning about right now in 220? Well, the importance is that when you have an argument that gets passed to a method, what Java actually does is copy the value that's inside the box for that argument, if you're thinking about our picture above. And that copy is what gets passed to the method. So think about that. If we're passing in information about my primitive data type, let me scroll up to that. It's going to pass a copy of what's inside the box. So it's going to pass a copy of the value 8. On the other hand, if I'm passing an array to my method, it's going to pass what's inside the box, which is the memory address or the reference to the other memory location. And that turns out to have kind of like cool implications with how we write the implementation for the method. Specifically, if a parameter happens to be a primitive type, it's passing a copy of that value into the method. So if inside the method body, you make changes to that copy, they're completely independent of the original. It's kind of like passing in a photocopy to the method. You're not passing like the original form, passing a copy of it instead. So if you like draw on it or crumple it up or tear it up, it doesn't matter. You still have the original copy back in your main program. On the other hand, if your parameter that you're passing into your method is a reference type, it passes in the memory location associated with the main program. And so your method is actually reaching back to that same memory location. And if you change the value that's stored there, it remains changed even after the method completes. So I know a lot of you during the semester have asked questions about, like, how could I write my method so that it returns 2 values instead of just 1 through the return type? And this is a way that you can do that. If you set up your method so that it uses reference types as the parameters, then when information is passed into that method, it'll be reaching back to the original memory locations in the main program, and it'll save all the changes that you make to those memory locations in the body of your method. So it's a way of returning multiple values from a single method.